Hello, my name is Michael James Katipay, and my topic is about indicators of water quality. So, water quality is a crucial biodiversity and life on our planet. So, understanding the principal water indicators and their parameters is key. Water quality is one of the most important health indicators in an ecosystem. Good quality water sustains human life, wildlife, and marine life, and is a key element of maintaining biodiversity. So, pollution is resulted from many situations. The source of pollution occurs at sea due to shipping and fishing activities, from sewage and wastewater discharges, agricultural and industrial practices, fuel spillage, and global warming. Water quality is often described by different indicators such as temperature, dissolved oxygen, pH, total dissolved solids, conductivity, suspended sediment, nutrients, metals, hydrocarbons, and industrial chemicals. Water quality is one of the most important factors in aquatic ecosystem and ensuring water is safe for human use and also for the wildlife and marine life. Action made on land have a major effect on what happens in water-based ecosystem, which is monitoring water quality levels is so important. So here's the six main indicators of water quality: temperature and dissolved oxygen, conventional variables, pH, total dissolved solids or TDS, nutrients, metals, hydrocarbons, and industrial chemicals. Number one is temperature and dissolved oxygen. So water temperature is one of the most important factors affecting water systems. Temperature can affect dissolved oxygen levels, chemical and biological processes, species, species compositions, water density and transmission, and stratification, and life stages in different marine organisms. Due to changes in external environmental conditions, water temperature fluctuates throughout the day and between seasons. And the temperature is freshwater system is heated by the sun, and although other water inputs such as precipitation, groundwater, and surface runoff can affect water temperatures. Heat is either lost or gained via condensation and evaporation, as you can see in the screen. The temperature of water affects the amount of dissolved oxygen water can hold. Water temperature increase, the amount of DO in water decrease. DO is the amount of oxygen dissolved in water, which can also fluctuate both daily and seasonally. Large fluctuations in DO can damage environmental ecosystems that are influenced stream flow, runoff, precipitation, and temperature changes. Fish and other aquatic animals and plants need DO to survive. Some organisms can adapt to changes. However, the majority are not able to. They can also affect the solubility and availability of nutrients in water. So number two is conventional variable pH, total dissolved solid, or TDS. So, conventional variables are indicators that are measured to understand aquatic environments, including drainage basins, local environmental conditions, and daily seasonal changes. So, pH, or potential of hydrogen, is a measurement of hydrogen ion concentration with this scale of 0 to 14, where 7 is neutral. The pH is the most natural water environment is between 6.0 and 8.5 pH, values below 4.5 and higher than 9.5 are considered lethal to aquatic organisms, and pH values less extreme can interfere with reproduction and other essential biology. So, metals, salts, and organic compounds can be affected to pH. In highly acidic water, some minerals dissolve in water, releasing metals and other chemical substances. pH levels can change from different water inputs such as runoff from land, groundwater, and even water draining from forest areas where weak organic acid and organic matter can alter pH levels. So this is the main sources of TDS are natural weathering, mining, industrial waste, agricultural, and sewage. In water, the higher the ion concentration, the more current can be conducted. Conductivity is dependent on the number of electrical ion charges and ion mobility and temperature. So, during periods of increased water flow, for example, from rainfall, the concentration of suspended sediment usually increases, and increased suspended sediment levels decrease light penetration in water and allows water to absorb more heat energy, increasing water increasing water temperatures. High concentration of suspended sediment can move plants, invertebrates, and other aquatic life that live in stream beds. Increased concentration can also affect food sources, decreasing aquatic fish populations. So number three, nutrients. So nutrients are essential for the growth and survival of living organisms. Nitrogen and phosphorus are extremely important in aquatic ecosystem, in addition to other elements like iron, magnesium, and copper. In aquatic system, nutrients are found in different chemical forms: organic and inorganic particulates, and dissolved organic and dissolved organic particulates. So, sewage, agricultural, fertilizer, and animal waste are all artificial sources of nutrients. Yeah. So, elevated concentration of nutrients usually come from direct discharge of wastewater system of runoff, which can limit primary productivity and enhance algae growth, which leads to eutrophication. So as you can see in the screen, the water has had algae, so and fish are die. So metals, copper, manganese, and zinc are imperative for biochemical forms that maintain life, but in high concentrations. This can become toxic if ingested by humans and animals, or humans that consume animals exposed to high concentrations. Metal toxicity and bioavailability depend on the form they occur and their oxidation states. Dissolved metals are the more toxic and bioavailable than metals that have been absorbed by sediments or bound with other molecules. The oxidation state bioavailability, toxicity, and solubility are influenced by other water indicators such as pH and DO. when metals accumulate in fish, uh, they can be passed on to humans during consumption. Mercury is especially uh, sus- susceptible to bioaccumulation, causing major risk to human health. So, based on my research, so Japan's in 1916 Minamata Bay disaster is a good example. So, industrial waste containing mercury was dumped, affecting thousands of people that ingested local fish and shellfish that have bioaccumulated the mercury in their tissues. So there's so many people died during that. As you can see in the screen, that's the metals in water. So number 5, hydrocarbons. Hydrocarbons are organic chemical compounds containing only carbon and hydrogen, polycyclic uh, aromatic hydrocarbon, or PAHs, are complex compounds that originate from fossil fuel, organic matter combustion, and chemical and biological transformations of organic molecules. They are known to cause cancer and are toxic to aquatic organisms when found in water. So hydrocarbons need to be regulated and controlled in water systems for the safety of human health and aquatic species and other animals in the ground. So this is the uh, photo of hydrocarbons, the hydrocarbons in water. So number six, industrial chemicals. Industrial chemicals can be introduced from industrial waste. Industrial chemicals such as PCBs, or as known uh, polychlorinated biphenyls. Due to the aquatic ecosystem and people that frequently that contaminated fish, PCBs are known to have negative effects on the immune system, nervous system, reproductive system, and endocrine system of living creatures, because PCBs can resist biological, chemical, and thermal degradation. It is extremely difficult to break them down in the water system. Summing up the main indicators of water quality. So water quality is so very important in terms of aquatic organisms and safe human usage, which is why testing the main indicators of water quality is thermals. Um, temperature dissolved oxygen, pH, and total dissolved solids, conductivity, suspended sediment, nutrients, metals, hydrocarbons, and industrial chemicals are the main indicators that can determine water quality. So that's all. Thank you for listening.
Hello, my name is Georgie Ceballos, BSIT, fourth year. My topic report is water pollution. What is water pollution? Water pollution is the contamination of water bodies. Example, lakes, river, ocean, and groundwater. Water pollution occurs when pollutants are discharged directly or directly into water bodies without adequate treatment to remove harmful compounds. Groundwater pollution. Water pollution affects plants and organisms living in these bodies of water, and in almost all cases the effect is damaging not only to individual species and population but also to the natural biological communities. Groundwater pollution is interaction between groundwater and surface water and complex. Consequently, groundwater pollution sometimes occurs as groundwater contamination is not easily classified as surface water pollution. By its very nature, groundwaters were susceptible contamination from sources that may not directly affect surface water bodies, and distinction of water non-point source may be irrelevant. A spill or releasing of chemical or radiation contaminants in soil located away from surface water body may not create point source or non-point source pollution, but contaminate the aquifer below, define toxin flow. Cause of water pollution. The specific contamination leading the pollution in water include wide spectrum of chemicals, pathogens, and physical or sensory changes such as relevant temperature and discoloration. Organic water pollutants, detergents, disinfection, byproduct found in chemical, inspected drinking water such as chloroform, food processing waste which can be including oxygen demanding substances, fats and grease, insecticides and herbicides, range organicides, another chemical compound. The organic pollution occurs when excess organic matter such as manure or sewage enters the water. Inorganic water pollutants, acidity caused by industrial discharge, especially sulfur dioxide from power plants, ammonia from food processing waste, chemical wastes, industrial byproduct, fertilizer containing nutrients, and phosphates. The inorganic pollutants are compound in inorganic products arising due to radiant energy and noise, heat, and example. Inorganic pollutants are arsenic, cadmium, lead, mercury, chromium, aluminum, and etc., which are found in stormwater runoff, agriculture, as well as commercial and classify water pollution. The major source of water pollution can be classified as municipal, industrial, and agriculture. Municipal water pollutants consist of wastewater from homes and commercial establishments. Local water pollution estimates suggest that nearly 1.5 billion people lack safe drinking water and that at least 5 million deaths per year can be attributed as waterborne diseases. With over 70% of the planet covered by ocean, people have long acted as if these very bodies of water, coal as serve as limitless dumping ground for waste, raw sewage, garbage, and oil spills, have begun to overwhelm the tilting capabilities of the ocean, and most coastal waters are now polluted, beaches around the world and are closed regularly, often because of high amount of the bacteria from sewage disposal, and marine wildlife is beginning to suffer. Water pollution can cause water because toxic to humans and environmental. Water is essential resource for all life on Earth. If a water source becomes contaminated due to pollution, it can lead to health issues, human such as cancer or cardiovascular condition.
Good evening, I'm Janica Flores from Group 4, and my topic is all about managing the Earth's water. What is water? Water is a substance composed of the chemical elements hydrogen and oxygen and existing in gaseous, liquid, and solid state. It tasteless and odorless liquid in room temperature. It has the important ability to dissolve many other substances. It acts as both a solvent and a delivery mechanism, dissolving essential vitamins and nutrients from food and delivering them to our body. Our bodies also use water to flush out toxins, regulate body temperature, and aid our metabolism. It is also always applied in indirect practices in our life such as cooking, bathing, laundry, and etc. What are the two types of water? Salt water and fresh water. Salt water may contain beneficial nutrients such as magnesium, potassium, and zinc, and have antibacterial properties. Soaking in mineral salt water may help relieve some skin conditions such as psoriasis. Fresh water is vital for life, supporting ecosystem and human civilization. We use fresh water in many aspects of daily life including food production, power generation, manufacturing, and sanitation. What is water management? Water management refers to activity that plan, develop, distribute, and manage the optimum use of water resources. It controls the movement of the water resources to minimize damage to life and property and to maximize efficient beneficial use. Everyone can do this, from local authorities to individuals at home. Good water management allows access to safe water for everyone. Water management helps in developing efficient irrigation practices for the betterment of agriculture in the country. Proper utilization of water in our homes can save this precious resource. Water management teaches us to use a limited amount of water whenever required. How can we manage water? Rainwater harvesting. Rainwater harvesting, or RWH, is a collection and storage of rain rather than allowing it to run off. Tamil Nadu was the first state to make rainwater harvesting compulsory for every building to avoid groundwater depletion. The scheme was launched in 2001 and has been implemented in all rural areas of Tamil Nadu. Posters all over Tamil Nadu, including rural areas, create awareness about harvesting rainwater. Rainwater harvesting reduces soil erosion and flood hazards by collecting rainwater and reducing the flow of stormwater to prevent urban flooding. Most buildings that utilize rainwater harvesting system have a built-in catchment areas on the top of their roof, which has a capacity of collecting large amount of water in case of rainstorms. Rainwater harvesting is very common in different countries, especially in the Philippines. Groundwater recharge. Groundwater recharge is the enhancement of natural groundwater supplies using man-made conveyances such as infiltrations, basins, trenches, dams, or injection wells. Aquifer storage and recovery, or ASR, is a specific type of groundwater recharge practices with the purpose of both augmenting groundwater resources and recovering the water in the future for various uses. Groundwater is found underground in the cracks and spaces in the soil and rocks. It is stored and moves slowly through geological formation of soil, sands, rocks, and aquifers. The largest use of groundwater is to irrigate crops. Groundwater is recharged naturally by rain and snow melt, and to a smaller extent by surface water, river, and lakes. Recharge may have embedded somewhat by human activities including paving development or logging. This activity can result in loss of topsoil resulting in reduced water infiltration, enhanced surface runoff, and reduction in recharge. The use of groundwater, especially for irrigation, may also lower the water tables. Artificial groundwater recharge. Groundwater levels are declining across the country as our withdrawals exceed the rate of aquifers to naturally replenish themselves, called recharge. One method of controlling declining water levels is by using artificial groundwater recharge. Artificial recharge is the practice of increasing the amount of water that enters an aquifer through human-controlled means. For example, groundwater can be artificially recharged by redirecting water across the land surface through canals, infiltration basins, and funds, adding irrigation furrows or sprinkler system, or simply injecting water directly into the subsurface through injection wells. Drip irrigation. Drip irrigation system distribute water to a network of bulbs, pipes, tubing, and emitters, depending on how well designed, installed, maintained, and operated. A drip irrigation system can be more efficient than other types of irrigation system, such as sprinkler or surface irrigation. Drip irrigation is the most effective, efficient water and nutrient delivery system for growing crops. It delivers water and nutrients directly to the plant's root zone in the right amounts at the right time. So each plant gets exactly what it needs when it needs to grow optimally. Greywater. Greywater is water from basins, bath, and shower that is piped to a surge tank. The greywater is held briefly in the tank before being discharged to an irrigation and treatment system. The greywater can be diverted either by gravity or by using a pump. The surge tank can be any type of container that is suitable for holding but not storing the initial surge of water. Greywater is gently used water from your bathroom, sinks, shower, tubs, and and washing machine. It is not water that has come from contact with feces, either from the toilet or from washing diapers. Grey waters may contain traces of dirt, food, grease, hair, and certain household cleaning products. While grey water looks dirty, it is a safe and even beneficial source of irrigation water in a yard. Sewage water treatment. Sewage Sewage treatment is a process of removing contaminants from municipal wastewater containing mainly household sewage plus some industrial wastewater. Physical, chemical, and biological processes are used to remove contaminants and produce treated wastewater that is safe enough for release into the environment. Sewage, sewage sludge is a byproduct of treated wastewater. It is composed of both organic and inorganic material, a large concentration of plant nutrients, organic chemicals, and as well as pathogens. Therefore, it is extremely important to properly treat such sludge in order to minimize its environmental precautions. These are the three processes on how to process the sewage water. Primary treatment. In primary treatment, sewage is stored in a basins where solids, sludge, can settle to the bottom and oil and lighter substances can rise to the top. These layers are then removed and then the remaining liquid can be sent to secondary treatment. Sewage sludge is treated in a separate process called sludge digestions. Secondary treatment. Secondary treatment to remove dissolved and suspended biological matter, often using microorganisms in a controlled environment. Most secondary treatment systems use aerobic bacteria which consume the organic components of the sewage, sugar, fat, and so on. Some systems use fixed film systems where the bacteria grow on filters. The water passes through them. The suspended growth system uses activated sludge where decomposing bacteria are mixed directly into the sewage. Because oxygen is critical to bacterial growth, and sewage is often mixed with air to facilitate decomposition. Tertiary treatment. Tertiary treatment, sometimes called effluent polishing, is used to further clean water when it is being discharged into a sensitive ecosystem. Several methods can be used to further disinfect sewage beyond primary and secondary treatment. Sand filtration and water is passed through a sand filter can be used to remove particulate matter. Wastewater may still have high levels of nutrients such as nitrogen and phosphorus. This can disrupt the nutrients balance of aquatic ecosystem and cause algae blooms and excessive weed growth. Phosphorus can be removed biologically in a process called enhanced biological phosphorus removal. In this process, specific bacteria called polyphosphate accumulate organisms that stores phosphate in their tissue. Conjunction use. Conjunctive use is a catch base for coordinate use of surface water and groundwater, literally going with the flow to maximize sufficient yield. Conjunctive use of groundwater and surface water in an irrigation setting is the process of using water from the two different sources of consumptive purposes. Conjunctive use can refer to the practices at the farm levels of sourcing water from both a well and from a irrigation delivery canal, or can refer to a strategic approach at the irrigation command level where surface water and groundwater inputs and centrally managed as an input to irrigation system. The planned conjunctive use of groundwater and surface water has the potential to offer benefits in terms of economic and social outcome through significantly increased water use efficiently. It supports greater food and fiber yield per unit of water use. Desalination. Desalination is a process that takes away mineral component from saline water. More generally, desalination refers to the removal of salt and minerals from a target substance, as in soil desalination, which is an issue for agriculture. Salt water is desalinated to produce water suitable for human consumption or irrigation. Desalination is used on many seagoing ships and submarines. Most of the modern interest in desalination is focused on the cost-effective provision of water for human use. Along with recycled waterways, it is one of the few rainfall-independent water resources. How we conserve water as an individual. Turning off the faucet while brushing your teeth, using water-saving toilets, installing a water-saving shower heads, taking shorter showers, only washing your clothes when necessary, fixing household leaks, using less water in the garden and when cleaning, not disposing of medical paints or other pollutants down the sinks. Put your garbage in a bin. So that's all. Thank you.
Good evening, ma'am. My name is Maria Eileen Encisa, and I'll be discussing about the layers of the earth, which is the crust, ocean crust, continental crust, stratosphere, lavosphere, mantle, outer core, and inner core. So, crust is the outer layer of the earth and similar to the skin of an apple because it has a thinner layer among the others. And it is made up of both continental and oceanic crust. And it is about 5 to 50 kilometers thick. So, oceanic crust. Oceanic crust is a thin layer of crust that overlies the ocean basins. It is more dense than continental crust. It is mostly basalt rock, and it is thinner than continental crust, and it is 5 to 10 kilometers, and it is younger than continental crust. So, continental crust is a layer of rock which forms the continents. It is less dense than oceanic crust and mostly granite. And it is thicker than oceanic crust and older than oceanic crust. Lithosphere. Lithosphere is a solid outer section of the earth which includes the crust, rocky layer, and it also includes the cool, dense, rigid part of the mantle. So, asthenosphere. Asthenosphere is a solid part of the upper mantle. It is weaker and less rigid. The crust moves over the plastic-like asthenosphere. These plates crash into each other. Here, the oceanic crust is subducting under the continental crust, which creates volcanoes. So, mantle. Mantle is the largest layer of the earth. It is under the crust and about 2,890 kilometers. It is composed of silicate rocks rich in magnesium and iron. The intense heat causes the rocks rise and then cool and sink. The process is called convection, which causes the crust to move. And the average temperature is 3,000 degrees. So, as you can see on the picture, the mantle is the second layer of the earth. And the next one is outer core. The outer core is a liquid layer, magma, and 2,300 kilometers thick and second largest. It is composed of liquid and nickel. It lies between inner core and mantle. Because the magma moves around the inner core, Earth's magnetic field is created. The average temperature is 4,000 to 5,000 degrees. So I have the example of the picture. So the outer core is the third layer of the Earth. So the next one is inner core. Inner core is a solid ball of metal. Because of intense pressure, It is 1,250 kilometer thick and it is made of solid nickel and iron. It is so hot that it melts everything in the outer core, and the spins at a speed faster than the Earth rotates. It is densest layer of the Earth, and the average temperature is 5,000 to 6,000 degrees. So I have the example of the inner core, which is the last layer of the Earth.
My name is Rico Rivera. My report is, what is the rock? A rock is a solid collection of minerals. There are three main types of rock. Sedimentary. Sedimentary rocks are recycled rocks formed by the deposition of fragments of material sediment that have been eroded and weathered from other parent rocks. They often consist of sand, pebbles, minerals, and mud that's been removed from the land by erosion, carried by rivers or blown by the wind, and eventually deposit. Igneous rock are formed by the cooling of a very hot molten material called magma, which originates deep inside the earth. There are two categories of igneous rock, extrusive and intrusive. The giant causeway in northern Ireland is an example of extrusive rock. A flow of lava cooled down slowly, developing cracks known as joints that created the basalts, granite from Peterhead in Scotland. This is an example of intrusive rock that solidified deep underground. Metamorphic rocks. Metamorphic rocks were originally a sedimentary rock, an igneous rock, or even another sort of metamorphic rock. Metamorphism literally means change in form. Rocks that are deeply buried underground can subject to very high temperatures and intense pressure. Being in this is the example of the rock cycle. All of its parts are connected to each changes, and the one part produce a change in another. And these are the question. Number 1. What are the three types of rock? Number 2. What are the two categories of igneous rock? That's we all. Thank you.
What is mineral? Mineral is a naturally occurring inorganic solid with definite chemical composition and an ordered atomic arrangement. So yung mineral is a naturally occurring substances means they are not made by humans, and it says mineral is inorganic because they have never been alive and they are not made up from plants or animals. Of course, minerals are solid because they are not liquid or gas, and minerals have a definite chemical composition because each one of them is made of a particular mix of chemical element. Quartz is a good example of a mineral with specific chemical composition, which is silicon dioxide. And minerals have an ordered atomic arrangement. That's why minerals grow as crystals. Metallic minerals. These are minerals serve as a potential source of metal and can be extracted through mining. Metallic minerals can further divided into two types, the ferrous and non-ferrous metals. So yung metallic metals, ito yung mga makikinig na crystals, and it contain metals, and we have two types of metals, the ferrous and non-ferrous metals. Yung ferrous metals, ito yung may iron. Example nun yung mga stainless steels, cast iron, carbon steel, and yung non-ferrous metals naman, ito yung mga walang iron. Example nito, aluminum, copper, brass, bronze, at maaari natin makuha yung mga metallic minerals sa pamamagitan ng pagmimina. And example ng metallic minerals ay iron ore, bauxite, hard metallic minerals and yung hard metallic minerals can be used as gems in jewelry. And it is usually found in igneous and metamorphic rock formations. Non-metallic minerals contain no metallic substances, and non-metallic minerals do not have any shine or luster. These minerals can be found in sedimentary rocks and young fault mountains.
Ito yung uri ng mga mineral na walang metal, and it is usually break down into pieces. And kadalasan siya nakikita sa sedimentary rocks and young fold mountains. Ang sample ng young fold mountains, yung Himalayas, and yung mga minerals na to ay ginagamit sa iba't ibang industries to manufacture different products. Example, mica is used in the electrical and electronics industry, while limestone and gypsum naman is used in the construction industry.